Hello, multivariable calculus students. This is Mr. Johnson, and we're going to do a quick derivative review before we start section 10.2. And so this is really the list that we give both A, B, and BC calculus students that has all the general derivative rules, so for instance, the product rule and the quotient rule and chain rule, as well as basically the derivatives that we use in single variable calculus, which it doesn't really change here in our class. We're going to utilize the same types of derivatives. I'm not going to throw anything really bizarre at you, at least at this point. And so you do need to know your basic derivatives. Things like the derivative of cosecant is really uncommon. Derivative of cotangent. You will see a little bit of derivative of tangent and secant, those types of things, but some of the ones that are a little less common in single variable calculus are also less common in multivariable calculus. But again, you should know these derivatives. These derivatives may come up at any point in our course, and when we start section 10.2, we'll start to perform derivatives with vector functions, and so this is just intended to be a quick review. I'm really not as concerned about derivatives as I am integration, just because I think that some of the techniques in integration are a little more difficult, but I wanted to make sure that you had a quick review of just some of the basic derivatives and a little bit of practice before we jump into section 10.2. Let's go to the next page and just try a couple of these together. So I'm going to do a couple and leave some for you to also try. Obviously, if you have questions on those, you can let me know and we can work through those together. I'll work through, this is all the problems here, and it's just a small handful. They're from the 2012 A, B, and BC exams. I just grabbed just a couple from those exams. There are obviously many problems that we could have done. These give a nice overview of basic derivatives. So this very first one from the A-B exam in 2012 is just the product rule. So if you remember the general product rule, if you have, let's say, f of x multiplied by g of x is equal to the first function times the derivative of the second plus the derivative of the first times the second, and you could flip this around, which often I'll do. I don't know why. I must have learned it that way, maybe in high school or college, but you can do this in any order. This is the formal definition in our text, but some other textbooks might have this flip-flop where you take the derivative of the first at the beginning and then flip the order. So with the addition, it doesn't matter. In this case, what we have is the function x and the function sine of x. And so when we take our derivative, we have dy dx equal to x multiplied by the derivative of sine, which is cosine, plus the derivative of x, which is 1, multiplied by the second function, which is sine of x. And it's a pretty quick answer. We get B. All right, we're going to skip 4. Let's try number 7. With number 7, I want to just quickly review the chain rule. So the chain rule is if you have a composite function, so let's say it's f of g of x, and you take the derivative, it's the derivative of the outside, and you leave the inside, then you multiply by the derivative of the inside. And this may happen multiple times if you have multiple composite functions within one, or maybe it's like a product rule or a quotient rule, and there's a composite function involved in that as well. So you might use this a couple times in a problem or in different contexts. But in this problem, we have the derivative of y equal to, and our outer function is the fifth power, and so we have the power rule where we bring the 5 down, we leave the inside, and we decrease that power by 1. And then we have to multiply by the derivative of the inside, which is, again, the power rule, 3x squared. And then we have minus, and the derivative of cosine is negative sine, so that turns into a plus sine of x like that. And that is option E. So again, these are pretty quick. Hopefully this is just a nice quick overview for you to just rekindle your love for derivatives. All right, let's go to the next page. I'm going to do one more with you. Okay, here I want to fast forward to number 7. This is actually now on the BC 2012 exam, and I want to do a quick implicit derivative review with you. So an implicit function is a function for which we would have x's and y's on one side. Now keep in mind that in multivariable calculus, all of a sudden we have three variables, and if you have x's and y's on one side of the equation, that's not considered implicit and multivariable because you may have like, z equals some function of x and y. So implicit and multivariable is when x, y, and z would maybe be on the same side of the equal sign. Something, where you have, I don't know, like x plus y squared times z plus 2 equals xz plus y, or some goofy thing like that. That would be considered implicit and multivariable because all three of your variables are mixed together. When we study this in single variable calculus, we're talking about x's and y's only, and implicit would be when they're sort of jumbled up, or maybe it's difficult to solve for one of them, or maybe if you solve for one of them, it just makes the problem a little bit more cumbersome. So in this case, this is an implicit equation the way it's written, and so if we're going to take the derivative of it with respect to x, we have arc sine of x and the natural log of y. So the derivative of arc sine of x is one that sometimes we forget. It's 1 over the square root of 1 minus x squared. And then the derivative of the natural log of y is 1 over y. But then this is implicit, and so we're multiplying by, because of the chain rule, the derivative of y with respect to x. And then our goal here is that we're trying to solve for the derivative of y with respect to x. So we're just going to simply multiply by y, and we get our final answer, which is letter A. So, and I'll actually be teaching you a kind of neat technique to do implicit derivatives really quickly in our course. We won't do that until chapter 11. Okay, that's going to be it for derivatives. That's a nice quick video, just a quick overview. Please practice these problems. There only are, I think, 8 problems. We just did 3 together. The next video will be focused on integration.